Thanks, everyone. Can you all hear? Great. Sounds like the mic is on. So are you ready for concurrent mode? Woo! I know. Let's talk about concurrent mode. And as Adam just said, hi, I'm Flarnie. It's nice to meet all of you. I work at Chegg. I previously worked on React Core. I should mention Chegg is hiring. I'm happy to talk about that. I also love talking about JavaScript, front-end, React. Feel free to ask me questions later if you have them. So let's talk about React. Who here likes React? I think, lots of people. It's a React conference, so I hope you like React. You've probably all had some good experiences with React because it allows us to write our UI code in a declarative style. We can do more with fewer lines of code. It updates the DOM in a performant way, paves over browser inconsistencies, lots of good stuff, right? But React is not perfect. In fact, my biggest complaint about React is a complaint I have about all JavaScript. So what's the problem? The problem is that JavaScript blocks the main thread. So for example, if I click something in a web application, when JavaScript is running, it's blocking the browser from responding to my click until JavaScript is finished running. You've run into this, I'm sure, in real web applications. For example, if you're trying to type into a text input and you're typing, and it does not respond. And you're like, what's going on? And the mouse might even turn into a little beach ball, and that is a clue that JavaScript is blocking the browser from responding to us, right? And so we wait, and if we're lucky, JavaScript finishes running, and the browser responds, but it's too late. We've had an awful user experience, right? Another symptom of this problem often happens when you're trying to scroll in a web application. So as we scroll through a list of items, the browser may be loading in those items and rendering them with JavaScript. And you can see in this example, it makes the scrolling kind of janky and stuttery. So it's because JavaScript, again, is blocking the main thread. How do we fix this? Enter React concurrent mode. The main idea is very simple. It's that when React is running and something like a click or an important event happens, then React will yield the main thread to the browser and allow the browser to handle that click or that update. Afterwards, React can come back and finish rendering. So this is great. We're not blocking the main thread anymore. But there's more. There's additional benefits that we've learned concurrent mode can unlock. For example, if we can control when we run different parts of our JavaScript, then we can potentially do something like pre-rendering, do some lower priority work when the browser is idle. So in this example, there's these 3 buttons at the bottom to show different views. If we're not clicking or scrolling, the browser is idle. It's not doing anything. So we can use this time to calculate what those views would look like. And then as soon as the user clicks, we're ready to update the DOM very fast. Another time when pre-rendering is really useful is during the initial page load. This is a time that's really performance sensitive. So looking at a timeline of the initial page load, it might look something like this. We often fetch some JavaScript, then we run the JavaScript, and then we may hit a point where we need to download either more JavaScript or some data. And we're waiting for that to come back before we can finish rendering with JavaScript. Whenever we're waiting for data, this is called being I/O bound. This is another time that we could do some lower priority rendering. Maybe we could prepare the code for the views that are below the fold, or views that are in a drop-down or a tab. So pre-rendering is a really important benefit. There are other benefits too, so I'll just kind of sum them up so we're on the same page. Why do we want React concurrent mode? Because it allows us to prioritize those important updates like clicks, user interactions, stop blocking the main thread. It allows us to deprioritize work that may not be needed, like a spinner. If data comes back very quickly, we can avoid rendering spinners at all. It allows us to do pre-rendering during idle time and I/O-bound time, and it can allow us to smooth out animations and video playback, again, because we're not blocking the main thread. So I don't know about you, but I need all of these things in my web apps, like today, yesterday even. It sounds great. So how do we prepare for this upcoming feature and get a deeper understanding? To get a deeper understanding, I'd like to bring all of you along on the story of some early experiments that I did at Facebook with React's concurrent mode in kind of preparing it for the upcoming release. So how do you prepare a feature for something like React that is so widely used and affects so many applications? How do we get this ready? A technique, I guess, an approach that I learned at Facebook, kind of to sum it up, is the idea that you build a feature, then you release it for just a few people, maybe just people on your team. You collect the bug reports and then fix those, then release it for more people, maybe just employees, and fix the bugs they report and then release it for more people, and you go through this cycle. So gradually you roll it out, fix the bugs, and eventually it's rolled out for everyone. This was the approach that the React core team used to release React Fiber, and I was inspired to use a similar approach when experimenting with concurrent mode. Now, at Facebook, I was experimenting on Facebook products, Facebook internal tools, but for the sake of this talk, I've translated everything to apply to kind of this to-do app, so the examples are very generalized, should translate to the sort of thing that anyone would build. So let's imagine that this to-do app, is our code, and we want to migrate it to concurrent mode. And for context, let's also assume that it's legacy code. You know how legacy code is. Maybe it's not always written in the ideal way. And for example, in this app, we can be aware that the to-do items and the text input are using React, but the header and the footer are not rendered with React. You might ask me, Flarnie, why is the whole app not rendered with React? Well, A, legacy code, sometimes it's just built a certain way and it can be hard to change. B, there are plenty of valid reasons that people mix different approaches. Could be that the header and the footer are using server-side rendering. Maybe the team has not adopted React server-side rendering. That's fine. So knowing all of this, let's take the first step so we can enable concurrent mode with this app, maybe just for the people in this room, and test it out. So to take that first step, we would wrap the root render call with React unstable create root, so this will render the whole app in concurrent mode. This is available today if you'd like to try it out yourself. And then the next step, let's load the app, try it out, see what bugs that we find. So just loading the page, we see a problem. The to-do items and the input are appearing after the header and the footer. The desired behavior is that everything appears at the same time. That's how it worked before we enabled concurrent mode, so what's going on? So if we dig in and look at some performance timelines, we'll see that before we enabled concurrent mode, this was how the code ran. First, we call react.dom.render, and then there's a JavaScript call to insert the header and the footer into the DOM. These all run synchronously in one frame. At the end of the frame, the browser paints, and we see all the content appear. Now that we've naively enabled concurrent mode, things happen differently. We still call react.dom.render, but under the hood, this puts the rendering work into a scheduling queue. And then it lets the browser do any work that the browser has to do, so that, for example, if you click or scroll, that would be handled. But in this case, the next browser work that's up to be done is that call to show the header and the footer. So that runs right away. Then the frame ends, the browser paints, and we see the header and footer appear early. In the next frame, because the browser is free, the scheduler can run the work that has been scheduled, and the React items appear, but it's too late. We have what's called tearing, where things are popping in at different times. So how do we fix this? What we need is to be able to also schedule that work to show the JavaScript header. We need to be able to tell the scheduler, hey, this work should actually happen after the React rendering work. So let's say we had a way to get access to that scheduler that React is using under the hood. So then, instead of actually running the function to insert the header and the footer, we could give it to the scheduler. Then when the scheduler starts running its work, it would run the rendering code and then insert the header and the footer. Everything appears at once. So what might this look like in code? So this is a very rough draft of what it might look like based on experiments that are ongoing. There is no final API for this, but just to explain, at the top, you see the original implementation, and it just calls that function to insert the header and the footer. So what we need to do is instead give that function to the scheduler. Maybe we would call a function called schedule callback. And that puts it into the same scheduling queue that the React work is in. Just to zoom in, again, this is not a real API, but it gives you an idea of what it might look like. Cool. So now that we've fixed this bug, the app actually seems to be working well. Let's roll it out to some more people and see what bugs they report. Our next bug report comes in, and people have noticed that sometimes, and when you're typing, the input feels laggy. And what we find is that there is a random set timeout callback that happens to fire occasionally during when someone is typing. So you can see here, if this set timeout callback fires and React is trying to update that input, React again will yield the main thread and the set timeout callback runs. Now in this case, we do not want the set timeout callback to interrupt React because updating a text input is higher priority than whatever that set timeout callback was. Maybe it was sending data to the server, maybe it was handling some data that came back, whatever it is, probably should not interrupt the user typing. So how do we fix this? We would take a similar approach. Once again, we need to schedule the work that's happening outside of React with the work that's happening in React. We need to coordinate between these things. So instead of giving some work to set timeout, we would give set timeout a callback that schedules the work. And we can specify that this callback should be lower priority than text input updates, like typing or any other high priority update. So now let's say we've coordinated all the work that's happening in our app, the work that's happening in React, and any other JavaScript that's running. So again, things seem to be running smoothly. So let's roll it out to some more people and see what bug reports we get. Maybe all of our employees can try it out. So this bug report only happens once in a while. It's kind of sporadic, but it happens that people try to create a to-do, and they end up with 2. And in fact, we're getting maybe a dozen other bug reports, but they're all kind of sporadic. They don't happen every time. I know you've probably had this experience before, where you get a bug report, and you're like, okay, I'm ready to debug. And you open up your development environment, take the steps to reproduce the bug, and it doesn't happen, and it's very frustrating. You can't use git bisect to find it. You may have trouble fixing it. It's hard if you can't reproduce a bug to figure out what's going on. At this point in the real story, I began to feel like the app was haunted, right? Like there were, like, gosh, just like that, right? It's like a poltergeist was moving things around when I wasn't looking. So luckily, I can explain for all of you the root cause of this issue, and then it won't be as mysterious for you. So going back to the duplicate to-do bug, the problem was that the call to save the new to-do item was being made in the component will mount of the new to-do item. You can imagine someone might have had the thought, oh, when we add this to-do to the list, I'll just save it to the server. Now, even when you're not in concurrent mode, this is an anti-pattern. We should not rely on when React mounts or unmounts components. That's an implementation detail. It's not a good place to put something like an API call. But in concurrent mode, this really can cause problems even more so, because the component will mount method could be called twice in certain circumstances. Now, to explain, we have to understand more about how React renders. So when React renders, there are 2 parts. The first part we call the render phase, and this is when React is updating the virtual DOM. And various lifecycle methods are called during the render phase. The second part is what we call the commit phase. It's very short, and this is when React updates the actual DOM nodes. And this is when component did mount, component did update, component will mount get called. So the first part, the render phase, this is when React might yield the main thread and there could be an interruption. If there's an interruption, React may have to stop and then start, and may even restart, depending on the circumstances. So that can lead to some of those lifecycle methods being called twice if React comes back and has to restart some work. So any lifecycle methods listed under the render phase are not safe places to put an API call or any other side effects. We should put them in the commit phase lifecycles, which will only be called once. So you might think, okay, I'll just move all side effects to the commit phase lifecycles, and that's good. The problem is, what we found with tons and tons of React components and teams using React at Facebook is that this anti-pattern of putting side effects in these render phase lifecycles was very widespread. There's a really big gotcha, and as I mentioned, it can cause bugs even when you're not using concurrent mode. So the React team made this improvement to the React API by beginning the process to deprecate some of those render phase lifecycle methods and replacing them with get-derived state from props and get snapshot before update. The names of these two new methods are very specific, and they should be a clue that it's not a good place to do something like save, make an API call or save something, any side effects. So let's say we remove all the deprecated lifecycle methods from our to-do app. We should be good, right? Well, I hate to break it to you, but it's still possible to run into these anti-patterns even if you remove all the deprecated lifecycle methods from your app. This is an example I actually have seen when people are migrating away from the deprecated lifecycle methods. They move code from component will mount into the constructor. And the problem is the constructor may also be called twice. In this example, the code we're moving creates a subscription to a backbone collection. So if we move it to the constructor and the constructor gets called twice, it would create two subscriptions. We normally clean up subscriptions in the component will unmount, which would only be fired once. So it would clean up one of the subscriptions. The other one would never be cleaned up, and this can cause a memory leak. The real solution in this example is to either move the code to component did mount, which will only be called once, or to make the call idempotent, meaning it will only create one subscription no matter how many times it's called. So with this understanding, let's say we remove all the side effects from the render phase for real. So now, again, we've squashed those sporadic bug reports that were coming in. Let's try rolling out our to-do app to our production users and see if any other problems get reported. So there's one more problem that comes in, and I'm going to use a really simplified example to explain this one. I call it the mutable store problem, and I find it fascinating. So hopefully this makes sense for all of you. To start, like I said, this is a more simplified example. It's a demo I wrote where the circles and boxes are a React component tree. Each circle is a component that reads its color directly from the color store, which is just an object we can see in the top right. And the buttons at the top will either re-render the React tree or change the color in the color store. So when things are working correctly, we would probably first change the color, toggle it to orange, and then we re-render our React tree. I slowed down the render just to make this easy to follow, and they all read the color orange. So I wonder what would happen if we click these buttons out of order, or in various orders. So let's see. So if we begin a re-render and then change the color in the middle, then React actually ends up committing a tree that's in an inconsistent state. So to explain what happened here, and this is real code, this can really happen, React began rendering and was calling the render method for each of those components. It called the render method on the first circle and the second circle, and they read the color blue from the store. Then when we clicked change color, React actually yielded so that the browser could handle that click. It's just a vanilla JavaScript click handler, and it changed the color in the store. So after that, React comes back and continues rendering these components. So it's calling the render method on each component, and when it gets to the third circle and calls the render method, that circle reads the color orange from the store. Now this might seem like a corner case, but again, it really does happen. And in the worst case, it could throw an error. Let's say I click a button and deleted the store completely. Then when those components try to read from it, they would throw saying, cannot read color of undefined. So how do we fix this? I'm gonna kind of summarize the fix, that there's at least two potential things. I think that ideally, React would handle this situation gracefully under the hood. So at the time that we ran into this, the team added some code that basically would catch any error thrown in this situation and restart the render synchronously from the root component. So that would force the tree to be in a consistent state. If the error is not thrown again, then it gets ignored, basically. But I would not rely on this. That's an implementation detail. And again, you could still have problems if an error is not thrown, but you may still have an inconsistent state with the tree. I would say that the real solution is to use references to an immutable store, such that if we change the color, it would create a new copy of the store, and the components would still have a reference to the old store. And to get the color change to propagate, you would re-render from the root using a reference to the new store. Cool. So let's say we fixed that bug, and now our app is actually running smoothly for all users. Congratulations. We've migrated our app into concurrent mode and released it. But I have to admit, there were some hiccups along the way. So what does this mean? We did not end up fixing any bugs in React, really. All of the problems that we ran into had to do with the way that we write our JavaScript code. So I would say that using concurrent mode is a different paradigm from the way that we've written JavaScript apps in the past. I think of it as being similar to a multi-threaded model. So the key idea, if you remember one thing from this talk, is that in concurrent mode, different pieces of work can be scheduled in a variety of ways, rather than always happening in the same order. I would also point out that, as you saw, for each problem we ran into, even with this legacy app, there were solutions. So that's encouraging, I think. And lucky for all of you, many of these solutions are wrapped up in React strict mode. So raise your hand if you've heard of or tried React strict mode. Oh, I don't see any hands. We should all go home and try React strict mode. The benefits are, super important if you want to try out concurrent mode. It warns you for those deprecated lifecycle methods, and in development, React strict mode will always double invoke the lifecycle methods, which could be called twice. So that means those ghostly, sporadic bugs we saw, they will always reproduce consistently if you use React strict mode in development. Even if you're not using concurrent mode, there are other helpful tips and warnings that get added in strict mode, so highly encourage trying it out. I also, think that when you are using concurrent mode, I have some other tips, so here's kind of a cheat sheet. I would start by using React strict mode and fix any problems that it flags. I would then coordinate all the work that's happening on the page, not just the work in React. I would avoid putting any side effects in the render phase lifecycle methods, move them to the commit phase. And I would also keep in mind that this is very new technology, and just experiment, try things out, share what you discover. And I have a bonus tip. I would highly recommend trying hooks and suspense with React concurrent mode. Now, you should still try them even if you're not using concurrent mode. They're great by themselves. But they also were developed with concurrent mode, so they should work very naturally together. With hooks, you don't have to worry as much, I think, about which lifecycle methods you're using. You're just using hooks. And with suspense, I predict that suspense may use or coordinate with concurrent mode for some of its features. So I recommend trying those together. And I would also encourage people to just experiment with JavaScript scheduling in general. This is the next big problem that we get to solve as web developers and framework developers. And the solution may not come from React. It may come from new browser APIs or other frameworks. So let's explore this new space. It's an exciting problem to solve. So in conclusion, I'd say that scheduling JavaScript is a paradigm evolution compared to the way that we've written JavaScript apps in the past. It has powerful potential. Use it with an understanding of the constraints that it imposes. So I'd like to thank a bunch of people. Thanks to Chegg Engineering for supporting me. Gosh. I should mention we're hiring again. Thanks to the React core team and web core team, the people I worked with during these experiments. Tora, thanks to ReactNext, and thanks to all of you. Thanks for joining me on this adventure.